Hello guys, I am Nida from Cybersecurity. In this session, we are going to discuss about the topic security issues and possible solutions of future-oriented optical access networks for 5G and beyond. Optical access networks are crucial for the development of 5G and beyond. However, they present unique security challenges that must be addressed to ensure the safe and reliable operation of the network. The overview of optical access networks are a critical component of modern telecommunications infrastructure. These enable high speed internet connectivity and support services such as voice over IP and video streaming. In this session, we will provide an overview of optical access networks, including their architecture, components, and key technologies. So, under architecture, the optical access networks typically consist of an optical line terminal, optical network unit, and optical distribution network. The components of optical access networks include fiber optic cable, optical splitters, and optical transceivers. The The passive optical networks are the most common technology used in optical access networks. When it comes to future oriented optical access networks for 5G and beyond, there are indeed some security issues to consider. Let's take a look at a few common concerns and possible solutions. Data privacy. So, with the increased data transmission and connectivity in 5G networks, ensuring data privacy becomes crucial. Implementing end to end encryption, secure key exchange protocols, and robust authentication mechanisms can help protect the privacy of the user data. Next, network slicing security. It is nothing but it allows the creation of virtual networks within a shared physical infrastructure. To ensure security in this context, it's important to implement strict isolation measures between network slices along with strong access control policies and monitoring systems. The other, virtualization security. As 5G networks rely on virtualized infrastructure, securing the virtualized environment becomes essential. Employing techniques like hypervisor security, secure virtual machine migration, and software defined networking security, these can help protect against potential vulnerabilities in the virtualized infrastructure. IoT security. 5G networks will enable massive connectivity for the Internet of Things. Securing IoT devices and the data they generate is crucial. Implementing strong authentication, secure communication, and regular security updates for IoT devices can help mitigate potential security risks. Network function virtualization security. So, the function virtualization allows the virtualization of network functions, which introduces new security challenges. Employing techniques like secure orchestration, secure virtual network function deployment, and regular security audits can help ensure the security of NFV environments. By addressing these security concerns and implementing appropriate solutions, future oriented optical access networks for 5G and beyond can provide secure and reliable communication services. It's important for network operators, service providers, and device manufacturers to collaborate and prioritize security in the design and implementation of these networks. The security challenges in future oriented optical access networks are many. Despite their benefits, optical access networks present unique security challenges that must be addressed to ensure the safe and reliable operation of the network. In this section, we will explore some of the key security challenges facing optical access networks and the strategies companies are using to address them. Cybersecurity threats. Optical access networks are vulnerable to a range of cyber attacks, including data breaches and deniable of service attacks. The physical security threats. It can also be physically compromised by unauthorized access or tampering. Spectrum analyzer attacks. Spectrum analyzers can be used to intercept and analyze signals in optical access networks, making them vulnerable to eavesdropping attacks. So, authentication and encryption mechanisms for securing optical access networks. Authentication and encryption are two key mechanisms used to secure optical access networks. In this section, we will explore some of the most effective authentication and encryption mechanisms used in optical access networks today. Advanced encryption standard. Advanced encryption standard is a symmetric encryption algorithm widely used to protect data in optical access networks. Transport layer security is a protocol used to secure communication between network endpoints, such as between a client and a server. Dynamic host configuration protocol is used to automatically assign IP addresses to devices in an optical access network. Snooping can prevent rogue servers from assigning IP addresses. We also have physical layer security techniques in optical access networks. Physical layer security techniques are used to secure optical access networks against threats such as eavesdropping and interference. In this section, we will explore some of the most effective physical layer security techniques used in optical access networks today. Light fidelity. Light fidelity uses light to transmit data, making it possible to secure optical access networks against eavesdropping by using physical barriers to block the transmission of light. Quantum key distribution. It is a technique that uses quantum states to securely distribute encryption keys between network endpoints. Optical time domain reflectometry uses pulses of light to locate faults in optical access networks, making it easier to detect and respond to physical security threats. The key management approaches for optical access networks are many. Effective key management is critical for securing optical access networks against threats such as data breaches and cyber attacks. In this section, we will explore some of the most effective key management approaches used in optical access networks today. Key rotation, key escrow, key distribution centers, public key infrastructure. These are some key management approaches. The security considerations for 5G and beyond in optical access networks are quantum computing, machine learning, blockchain. Quantum computing represents a significant threat to the security of optical access networks as it could potentially break existing encryption methods. The machine learning algorithms can be used to identify patterns in network traffic, making it easier for attackers to launch successful cyber attacks. Blockchain could provide a more secure alternative to existing key management approaches, enabling more secure communication and authentication in optical access networks. So, now let's conclude this. The future directions for securing optical access networks. Uh, we have to conclude now. Securing optical access networks is a critical challenge facing telecommunication companies today. With the ongoing evolution of 5G and other future technologies, it is important to continue developing innovative new approaches to ensure the safe and reliable operations. Thank you.